All right. So now we're going to look at A triple I. In A triple I, we're asked to find or calculate the bearing of B from F. All right. I actually did not like this part of the question, to calculate the bearing of B from F, because I don't think we got enough information to do the question. And in order to do it, I'm going to make an assumption. All right. Now, I got no evidence from the question that this assumption is true, but I'm going to make an assumption just to do the question. All right. But personally, I don't think that there was enough information in the question to do the question. All right. So we're asked to determine the bearing of B from F. So let's go down to this diagram. All right. Now, the assumption I'm going to make is that A is east of F. That's the assumption. So if I draw my north, south, east, west line, it would look something like this. Since I'm taking the bearing from F, at F, I'm going to draw my north, south, east, west line. Now this is the bearing of B from F. Bearing is measured clockwise starting from north. So I need that entire angle. The first piece of it I know. The angle between north and east is 90 degrees. And we also know this is theta, which we found to be 14 degrees. So I can simply say, let's go to the next page, that triple I, the bearing of B from F is equal to 90 plus 14 is equal to 104 degrees. All right. So as I said, we have to make an assumption in order to do the question, because and personally, I don't think that we had enough information. If I'm wrong, I guess somebody can always correct me. Now, let's go now and look at the B part of the question, which is the last part of the question. In B, we're told, given that the area of triangle BTA, all right, so I'm going to change the ink again. This is triangle BTA. It's a triangle at the front. It's sort of like if this was a solid shape, BTA would be that triangle at the front. So given that the area of triangle BTA is 21.8 meters square, and that AT is 15.7 meters, so this is 15.7 meters, we're to calculate the size of angle BTA. So we're being asked to find this angle here, angle BTA. Let's call it, we use alpha already. Let's call it alpha. All right, let's call it alpha. All right, so I'm going to draw a diagram associated with this. So B part of the question. So I'm redrawing that triangle BTA. This is B. No, this is B. Over here was A. So this is A, this is T. We're told that this is 15.7 meters. We don't know this. I'm going to call it X. This is 40. This is 4.2. This is 4.2 meters. All right, and we're being asked to find this angle here. Call it alpha. And we're told that the area of triangle BTA is 28.1 meters square. All right, so here's what I know. If I know the size of this angle here, if I know the length of X, which is BT, I can use calculation. I can use this area, because we're told we're given this area. So if I could use the area then to find the angle. All right, and that is providing I can determine the size of BT. All right, so let's go back and look at BT in the diagram. You can see that BT is this triangle here. All right, we have used X and Y. I'm going to call it Z. The length of BT, this is the length of BT. This is the hypotenuse. BT is the hypotenuse of the triangle. And the 12 meters is the adjacent. And the ratio that includes adjacent and the hypotenuse is cosine. All right, so I'm going to use that knowledge now to determine the length of BT. All right, so BT, finding BT, and remember BT was the cosine, is the hypotenuse of an angle, and I'm going to say cos is equal to adjacent over hypotenuse. Then I'm going to say the cosine of 28 degrees is equal to adjacent BT. The adjacent was what? The adjacent was 12 over the hypotenuse, which is BT. The hypotenuse, which is BT. All right. Then now, if I have one fraction is equal to one fraction, I'm going to cross multiply. So this is BT cosine 28 degrees is equal to 12. All right, 12 was the adjacent and BT was the hypotenuse. So if I divide both sides by the cosine of 28, I'm going to get BT to be equal to, so this is 12 divided by the cosine of 28. I'm going to get BT to be 13.6 meters. So this is 13.6 meters. All right, so this is 13.6. All right, now I'm going to use the area. Now, the area of a non-right angle triangle, if you're given the length of two sides and the inclusive angle, it's a half AB sine C. So therefore, a half times A, let's make that 13.6, times B, 15.7. The sine of the angle between them, which is alpha, is equal to 28.1. So into this goes 6.8. So this is 6.8 times 15.7, which is equal to 106.76. The sine of alpha is equal to 28.1. Divide both sides by 106.76. 106.76. I'm going to get the sine of alpha is equal to 28.1 over 106.76. And of course, if I know the sine of an angle, to find the angle, I must use sine inverse. So angle alpha, which is angle BTA, is equal to sine inverse 28.1 over 106.76. So angle BTA is equal to shift sine open bracket 28.1 divided by 106.76 close bracket equal. This angle is 15.3 degrees. So the angle DTA is 15.3 degrees. It's a three significant figure.